Hi everyone, it's Math with AUB, keeping in view sky's the limit and beyond. Let me start IBA-Direct preparation. I have selected some elegant questions, standard questions. Without wasting time, let's indulge into them. Our first question reads as find the unit digit of 5 to the power 100 plus 1 times 55 to the power 100 plus 2 times 555 to the power 100 plus 3. Find its unit digit. Find its unit digit. Find its unit digit means we are interested in the last digit. We are interested in the last digit. The prime quality of 5 is whatever the power of 5 power 1 results in 5 square results in 25, 5 cube results in 125, 5 raised 4 results in 625, and so on. From this, one can infer that whatever the power of 5 is, its last digit is always 5. Last digit or unit digit. Last digit or unit digit is always 5. 5 having any integral power, 5 having any integral power, integral means positive integer power, always leads us to last digit 5. It will give last digit 5, last digit 5. So I can simplify this, its last digit is 5 plus 1. Whatever the power of 5 is, last digit is always 5. It will give me 5 plus 2. And this one is also 5. Last digit is 5. It will give also last digit 5. 5 plus 3. Now it's really simple question. 5 plus 1, 6. 7 times 8. So we have 6 times 7 times 8. One can multiply 42, 6 7 the 42 times 8, 8 to the 16, 1 carry, 8 4 the 32 and 133, 336. So our last digit in that case is 6. Our last digit, our unit digit, our last digit, our unit digit is 6 in that case. 6 is our answer. 6 is an answer. The science or chemistry or nomenclature behind this is that whatever the power of 5 is, the last digit is always 5. The last digit is 5. That is ample proof here that I have described to you. 5 raised 1 is 5, 5 square 25, and so on. One can verify 5 power 5, 5 power 6, and so on. The last digit is 5. I have written very elegantly 5 plus 1. The last digit is 5 plus 1. The last digit is 5 plus 2. The last digit is 5 plus 3. So I have manipulated, just multiply them. 6 times 7 times 8. Multiply them, it is 336. So our last digit is 6 in that case. Simple enough. Let's move to question number 2. Let's move to question number 2. Our question number 2 is simple, based on radical third, how to get rid of square root. Nothing behind this. Nothing beyond this. 2 to the power 3 times 5 times n. What is the smallest positive integer n? For what value of n? For what smallest value of n, this will become an integer. This will become an integer. Integer means a perfect square quantity. Perfect square quantity that gives us a positive integer root. Positive integer root means what we replace here, the value of n, the minimum one, the smallest one, to make this perfect square. To make this perfect square, here one can write 2 cube as 2 times 2 times 2 times 5. Here one pair of 2, it's okay. Dearth of 2 as well as here is dearth of 5. So if I can write n is 2 into 5, then it will compensate my deficiency. Pair of 2, it's good. Another pair of 2, well and good. Pair of 5, excellent one. So n is 2 times 5. So value of n is 10. The smallest positive value of n, that gives us an integer. Integer means we can easily get rid of this square root. Getting square root is tantamount to finding a perfect square quantity. Perfect square quantity. Now it is a perfect square quantity. 2 times 2, again 2 times 2, 5 times 5. So pair of 2, another pair of 2 and 5, 20 is the result. Look, 20 is the integer and we are outside the radical sign. That's our answer, 20. If we plug in, if we switch value of n is equal to 10, n is equal to 10, n is equal to 10, then we are going to have 2 to the power 3 times 5 times n results in a perfect square. The result of perfect square from a radical. If perfect square is present in a radical, it will give us an integer. It will give us an integer. Otherwise not. R1 can simply plug in 1. It doesn't work. Plug in 2. Then pairs of 2 are complete, but 5 is missing. If we plug in 5, the deficiency of 5 will be removed. Still there is a deficiency of 2. If we can write 10, both deficiency of a 2 as well as 5 have been compensated by utilizing the value of n is equal to 10. Here the value of n is equal to 10. When square root gives us an integer, when the result of square root inside is a perfect square quantity. Perfect square quantity results, the radical, the square root or radical of a perfect square quantity always results in an integer. Always results in an integer. Results in an integer. So that is the logic behind this. How to get rid of this, or simply at your 8th or 9th grade, how to make pairs. I have written 2 into 2 into 2, then 5, then n. Then I have realized I need another 2 and another 5. So 2 5 are 10, that is the value of n I have selected from the option. Okay, moving towards further. This is based on simple arithmetic. How to add fractions. How to add fractions in case of powers. In case of power exponent. Let's see. That is 6th root of s to the power 5. 9th root of s is equivalent to what? Let's see and find out. I have 6th root of s raised to the power 5 times 9th root of the letter s. This one can be written as s to the power of 506 times s raised 1 over 9. Whatever is present here, we have to write in fraction. 1 over. There is 5, I have written 506. There is 9, 1 is always there, I have written 1 over 9. Bases are same, they are in addition, just they are in multiplication, sorry. Bases are same, they are in multiplication, add the powers, write base 1 times 5 over 6 plus 1 over 9. 5 over 6 plus 1 over 9. S. Take LCM. I take simple LCM. Whatever the denominators are, just multiply them. 9 here, 9 times 45. 6 times 1, it's 6. S to the power of 45 plus 6, that's our 51. 6 9 the 54. Applying table of 3. Table of 3, 1 times 2 carries 7. Overall, table of 3 1 time, and here it will become 8. What about this 51? 1 time. 51 divided by 3 1 times. 1 3 the 3. There's 21. Yes, then 7. 17 over 18. So this denominator power can be written as s raised to 17. This one can be written as 18. So 18th root of s raised to 17. The result is 18th root of s to the power 17. S to the power 17. Simple logic is that if that's the power x raised m over n, it can be written as nth root of x raised m. It can be written as nth root of x raised m. Nth root of x raised m. So our answer in that case is option number D. Option number D. It's our answer. What we have done? 6 root of s raised 5 can be written as s to the power of 5 over 6. And 9th root of s can be written as s raised 1 over 9. Here bases are same. They are in multiplication, just add their powers. I used to done simple LCM. Multiply the denominators whatever they are. 9 5 the 45, 1 6 the 6. 45 6, 51 over 50. 4, apply table of 3. 1 times 2 carry, 7 3 the 21 and add is 18. Whatever is in the denominator, that is going to be our root. 18th root of s raised 17. 18th root of s raised 17 is our answer in that case. Moving to another question. Inequality, just simply plug in the values, whatever the options given are, and check the validity of the inequality and it's our answer. Simple one, simple enough. For which value of n, for what value of n, values are also mentioned. 2 raised n is greater than n square. 2 raised n is greater than n square. 2 raised n is greater than n square. Look, n is equal to 4, start from 4, put n is equal to 4. 2 raised 4 is greater than 4 square. 2 raised 4 means 16, greater than 16. No, inequality is not valid. 16 is not greater than 16. 16 is not greater than 16. So it doesn't work. Check another option. Check another option, that is 2, put n is equal to 5. Greater than or equal to 5. Put n is equal to 5. 2 to the power 5 greater than 5 square. 2 to the power 5. 2 into 2 into 2, 5 times. 32 is greater than 25 square. Yes, inequality is valid. Inequality is valid. So our right option is n is greater than or equal to 5. N is greater than or equal to 5. There is a slight difference. In that case, we have to take the values n is equal to 6. N is equal to 6. Then we are going to miss n is equal to 5. Then we are going to miss n is equal to 5. So this is our right option. There is a fine line between this and this option. They only differ in that case 5 is included and in that case 5 is excluded. 5 is excluded. 5 is included, 5 is excluded, and n is equal to 5 satisfy this inequality. So this is our best option. This is our best option. Moving towards question number 5. If the ratio of a over b is equal to 2, if a over b is equal to 2, then what is the value of 4b over a? 4b over a. If the given part a over b is equal to, if the given portion, then we have to find 4b over a. 4b over a. There is no need to find the values of a and b. Simply write a in terms of b. Write a in terms of b. A is going to be 2 times b. A is going to be 2 times b. I have switched from left to right, from division to multiplication. A is equal to b. Insert here instead of b, instead of a, instead of a, write 2b. 4b over 2b. b cancelled out. 2 is the answer. 2 is the answer. So our right option in that case is 2. So our right option in that case is 2. Don't you worry. Take b here, from division to multiplication. On the left hand side it is in division, it is in multiplication. A is equal to b. Just plug in this value instead of a. Just plug this value of a. b cancel out. 2 to the 4. 2 is our answer. 2 is our answer in that case. Question number next. What is the sum of all positive prime integers less than 10? Less than 10. It is a question based on understanding that you should be familiar of the familiar from prime numbers. Prime number has exactly 2 divisors. Prime numbers has exactly 2 divisors. The confusion lies in 1 and 2. The confusion lies in 1 and 2. 1 is not a prime. 1 is not a prime. 1 is not a prime, and 2 is only even prime. 2 is only even prime. The rest prime or odd. The rest prime or odd. The main confusion lies here. Most students take 1 as a prime. 1 is not a prime. 1 is not a prime. 1 has only one divisor. 1 has only one divisor. While one definition of prime number is it has exactly 2 divisors. 1 and itself. 1 and itself. Like 2. 2 is divisible by 2 as well as by 1. Second, the rest of the prime numbers are odd integers except 2. 2 is the only even prime. 2 is the only even prime. 2 is the only even prime. Now let's move to question. Find the sum of all positive prime integers less than 12. 1 is not a prime, 2 is a prime, 3 is a prime, 5 is a prime, 7 is a prime, 11 is outside this range. We have been restricted less than 10, less than 10. So these are our prime numbers. 2, 3, 5, 7. We are interested in their sum. Really very easy. 2 plus 3 plus 5 plus 7. It will become 17. It will become 17. It will become 17. So the sum of all prime numbers less than 10, sum of all prime numbers less than 10 is 17. Is 17. Is 17. Mark my words, 1 is not a prime. According to the definition of prime number, prime has exactly two divisors, 1 and itself, 1 and itself. So 1 has only one divisor, 1 is not a prime, while 2 is the only even prime, Okay, moving towards final question, the seventh one, last but not least. If 75% of 2024 is x, so value of x is 75% of 2020 and 2024% of 75 is y, then what is the value of 2x plus 2y divided by 6? We have given x is equal to 75% of 2024 and while y is 75 times 2024%. Then find 2x plus 2y divided by 6. 2x plus 2y divided by 6. Just plug in the values of x and y, we are going to get through. Here it is x, 2 times x is 75% multiplied by 2024. Okay, let me write some here in order to save some space for you. 2 times 75% multiplied by 2024 plus 2 times 75 times 2024% divided by 6. If we remove this percent, divide by 100. If we remove this percent, divide by 100. So overall it is divided by 100. It will become 2 times 75 times 2024 plus 2 times 75 times 2024 over 100 times 6. 100 times 6. Look, overall 100 in that case. Divided by 100 after removing percent, then 6 will be 100 will be in the multiplication of 6. 100 times 6. Now apply table. Just it is simple. 150. Let me cancel out here. 50 times. Apply table of 25. 2 times. Here 3. Then 3 to the 6. 3 to the 6. Let me still simplify this situation for you by taking common and simply dividing. Okay, let me manage some space. Now it's cool. Now I have got enough space. We are interested in 2x plus 2y divided by 6. Just plug in the value of x. It is 75% of 2024 and 2 times 75 times 2024% divided by 6. Okay. Remove percent, divide by 100, remove percent, divide by 100 stepwise. 2 times 75 divided by 100. 2024 plus 2 times 75 times 2024 divided by 100. Let me write divided by 6 here, 1 over 6. Now 2 times 75, this one, look at us. 2 times 75 times 2024. 2 times 75 times 2024, and denominators are identical. So I can write 1 over 6. 2 times 2 plus 2, 4. 4 times 75 into 2024 divided by 100. It's very cool now. Applying table of 4, 25 times, table of 25, 3 times, then table of 2, here it will become 2 over 24 divided by 2. So our eventual answer is 1012. Look at this. Both these quantities are same. 2 times 75 times 2024 divided by 100. 2 times 75 times 2024 divided by 100. I have merged them. 2 plus 2, 4. 2 plus 2, 4 means 4 times 75 times 2024. Then apply table, whatever the cancellation is. So our answer is in that case is 1012. So our right option in that case is 1012. It's my tiny effort for you guys. in collection of 23 series. This is, I think, 10th or 11. Let's solve by itself next.